Hi, I'm Greg Garrett. I'm the Director of Technical Services for the National Plaster Council. One of the frequent calls that I get nationwide is on a phenomena that we call etching deterioration, or sometimes referred to in a slang term called spot etching. Spot etching has been around since, at least since I've been in the industry, which is 1969. When I started working in the industry with my father going back to 1969, I started looking at pools. The two primary sanitizers at that time were calcium hypochlorite with a pH of 11.7, 11.8, and then also liquid chlorine with a pH over 12. Two very base sanitizers. In 1965, they came out with what they call stabilized chlorine. That's trichlorochlorine. A lot of people know it as the 3-inch white hockey pucks. Can also be granular product, and another granular product was sodium dichloro. And these products had conditioner or stabilizer actually built into the product. So we went from non-stabilized chlorines with high pHs to all of a sudden we're using acidic sanitizers. Trichlor has a pH, depending on the manufacturer, between 2.8, 3.5, but they have both one thing in common. They have stabilizer in them. So all of a sudden now what we saw was the introduction of stabilized chlorines, and our products began to change. Plaster back in the mid-60s, late 60s, early 70s were usually just typically Type 1 white cement, ASTM C150 white cement, and marble sand, also sometimes called limestone. It could be sedimentary limestone, but usually metamorphic limestone, or a product that was calcium carbonate. Back in the 50s and early 60s, they were using silica sand, which was much harder, but because of yellowing problems, discoloration problems associated with the use of that product, the industry very gradually moved away from it and went to white marble sands as a method to achieve a long-term white looking product. Well, what happens is the principal ingredient in marble sand pools is calcium carbonate. And when you mix cement with water, you form 5 principal compounds. Those 5 principal compounds, it's not important that you remember them except for one component. Those 5 principal compounds are tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite, and calcium hydroxide. Calcium hydroxide, think of it as the weak link in the armor. Calcium hydroxide is a very soluble material. So when you react cement with water, 24 to 27% of what you form from that reaction with that cement is calcium hydroxide. Why is that a problem? It's so soluble that if the water becomes aggressive, even mildly aggressive, for periods of time, it will begin to be dissolved, to break down. Where does calcium hydroxide like to form in a plaster matrix? Whenever you mix cement with water, you form cement paste, or what we call the principal binder. It's what holds the rock. This is a rock or an aggregate, and the cement paste encapsulates that aggregate. Well, in that reaction of the white cement, and when it forms that paste, it encapsulates that aggregate, but there's a special region between the aggregate particle and the cement paste called an ITZ. That stands for an interfacial transition zone. This is something that's unique to all cementitious materials, not just pool plaster, but the ITZ in that specialized region, and usually it's defined as being somewhere between, most scientists have recognized as being between 20 to 50 micrometers. That's very, very small, very tiny. But this specialized region has got 3 things that makes it unique. Number 1, calcium hydroxide exists there. Number 2, it's got a higher water cement ratio than the bulk paste. And number 3, what makes it special is the fact that it's very porous. So imagine a scenario where you're using trichlorochlorine. You're putting it in, but for every 1 pound of trichlor, you're also putting in a secondary product besides chlorine. You're putting in stabilizer, conditioner, and over time, the stabilizer is going to slowly creep up, 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 and up. When it does, if you don't understand the nature of that product, you're going to have an issue with elevated cyanuric acid or stabilizer levels. And for example, the best test kit on the market, which is a tailored test kit, in my opinion, on page 30 of the test kit booklet that's included in this test kit, they say that you must be aware that with the use of stabilized chlorine products, you are going to get into a scenario where you get what's called over-stabilization. In other words, the stabilizer will climb to such a point that it goes from being a positive thing. People ask me, why do you have stabilizer in water to begin with? It's to prevent ultraviolet rays in sunlight from breaking down the chlorine. But it's also part of every tab or every pound of sodium dichloro. Approximately slightly over 50% of that product is stabilizer. So over time, as you put it in on a daily basis, you're putting the tabs in the floater or the feeder, it's going to cause that level to go up. When that level goes up, you have to take action to prevent this overstabilization. If not, you can get different effects from that elevated stabilizer level. The most significant effect is the fact that if you don't understand that the stabilized chlorine is going to affect what's called carbonate alkalinity. What is carbonate alkalinity? It's known as several different names: adjusted alkalinity or corrected alkalinity. But what you do is you test the alkalinity in the water. You take approximately 1/3, this is a field rule, 1/3 of your stabilizer content, and you subtract it from your tested alkalinity. That gives you carbonate alkalinity. Now, why is that important? Because you have to remember, it is only carbonate or adjusted alkalinity that can be used to determine whether the water is balanced. Balanced according to what? To a mathematical way of calculating balance called the Langmuir saturation index, or we shortened it to, in the pool industry, to the saturation index. Every single major trade association in the United States recognizes the use of the saturation index to determine, is your water in balance or not balanced? Is it in an etching or leaching mode, or is it in a scaling or precipitative mode? And so both of these levels, super low or super high, saturation index levels can create problems. If it's too high, you can get scale. You can get staining, mineral precipitation. If it's too low, you can get etching or leaching. So one of the things that we focus on in the MPC is instructing people everything from our startup certification program to our technical bulletins to our tech manual about this concept of, number one, only use carbonate alkalinity to determine if water is in balance, especially when using the saturation index. And number two, understand the relationship of stabilized chlorine and its effect in pool water to create changes in the carbonate alkalinity and ultimately the saturation index. It gets a little technical, but there are many mathematical little programs. There are now apps that are on, for example, smartphones and others, that literally you just plug in the variables in your pool water as you're testing it, and it will calculate the saturation index for you. So one of the things that we began to notice back in the late 60s, early 70s, was that the more of these stabilized chlorines that we went to, which are again acidic, and as we moved away as an industry from liquid chlorine and cal-hypo, which are calcium hypochlorite, which are base compounds, that we began to see changes in the surface. Because white cement's been around forever, and marble sand pools have been around for a long time, but we began to notice this little spotting effect. And so we began as an industry to look at this, and to that, it led ultimately to what's called the National Pool Industry Research Center at Cal Poly State University, San Luis Obispo, California. And on the campus, the university, in concert with initially the MPC, but we ultimately brought in other trade associations, built 14 pools and spas up on the campus. And these 14 pools and spas, we were going to put through various things to test a variety of theories that have been put forth over time. Theories such as, is calcium chloride a factor? And what is calcium chloride? It's a set accelerator that's used in cooler temperatures to accelerate plaster so it will set in colder weather. But calcium chloride is real interesting because if you have low calcium in the water itself, what do we put in it to raise it? Calcium chloride. So it serves multiple functions in our industry.